Hello all, I'm Anshul Shah. I'm a PhD student at Johns Hopkins University. Today I will be presenting our work on pose and joint aware action recognition. There has been a lot of interest in the area of action recognition with improvements to the spatiotemporal modeling, faster models, and devising methods to reason over very long videos. All of these approaches make use of appearance or dense optical flow as the input. In contrast, in this paper we deal with pose-based action recognition. Specifically, given a video, we extract human pose using an off-the-shelf pose extractor, which is then used as input to the model. So why pose-based action recognition? Experiments in psychology have shown the importance of moving joints for human motion perception. These joints can succinctly convey most information required for action recognition. Further, the use of sparse pose information instead of appearance can help reduce the impact of scene and object biases which plague the current action recognition systems. Some of the past works in this area include works like Potion, which develops a new pose encoding and a model for joint-based action recognition. In PA3D, the authors propose a new framework with a novel temporal pose convolution to improve performance. SIPNet extracts features from the pose extractor and applies 1D temporal convolution to infer activities. While the field has made impressive strides, there are still a few issues with these systems which we try to address in our work. Our first contribution is a simple data augmentation step that respects the geometry of actions. Our model, named JMRN, extracts better features by separating per-joint reasoning and inter-joint reasoning. We also introduce a novel joint contrastive loss to learn better features. Our approach does not require tracking, which is difficult for in-the-wild videos. We work with joint heat maps alone instead of relying on additional inputs from the pose extractor or ensemble of models like some prior approaches. Our approach is modular, and we can easily replace the different components including the pose extractor. Given the encoding extracted using Potion, we apply our novel data augmentation step. Our pose-aware augmentation is a cascade of two operations. The first is a random global jitter of the entire input representation. This helps the network learn that the action is not strongly dependent on the global position of joint trajectories. The second divides the pose into 6 groups of joints, like head, torso, and each joint representation is jittered as a group. The augmentation applied is frame-wise consistent, which ensures that we preserve the geometric integrity of actions. Previous approaches work with collective joint reasoning from the first step. This can lead to the model not exploiting useful per-joint motion signatures. Instead, we propose to separate per-joint feature extraction and inter-joint reasoning module. We first extract per-joint motion information using a shared encoder. Next, we have an inter-joint reasoning module which extracts weights for each joint conditional on the input. These weights are then used to reweigh the per-joint features, which are then combined and used by the subsequent layers for final classification. In this work, we also propose a novel joint contrastive loss. A loss enforces class-level consistency on the per-joint mid-level features. It can be seen as a variant of the supervised contrastive loss, but different from prior works, our loss operates on mid-level features and is applied joint-wise. We use Potion as a baseline and retains the same motion encoding for fair comparison. We see that the use of JMRN, pose-aware augmentation, and the joint contrastive loss leads to consistent improvements. Next, we compare our approach to the recent state-of-the-art which make use of pose information. We see that we outperform the state-of-the-art which use pose alone by a significant margin on all the three datasets. As alluded to earlier, the use of pose information can help the model be robust to scene and object biases. Mimetics is a dataset proposed to evaluate an action recognition model on out-of-context actions. Our proposed approach outperforms the previous baseline on this dataset. Finally, we evaluate the performance of our model on late fusion with RGB-based models. We see that late fusion leads to non-trivial gains on many classes. Please refer to the paper for additional information. The code and pre-processed data is available on this GitHub page. Thank you.